My name is David. I'm a computer scientist, and I have been working on solving the Liber Primus for about a year now. About 6 months ago, I discovered what I believe to be a kind of key for solving the Liber Primus, or at least large portions of it. In the 6 months since I've discovered this, I have tried various ways to apply this to get a decryption from the text. So far, nothing has worked. Now, there are many things that I have not tried, and I'm sure many things I've not even thought of. Now, unfortunately, I have some health concerns which have progressed recently and are now taking up a pretty significant portion of my time and energy, so I don't have as much ability to work on this as I used to. And if this is as important as I think it is to solving the Liber Primus, I know I would be doing those who are still trying to solve it a great disservice by not at least putting it out there and seeing what the community can do with it. So that's what I'm doing here. Basically that's it. I'm David, and this is what I'm referring to as the Compass Cipher. Okay, so let's talk about this first. This is the last communication we received from Cicada in 2016. A lot of people, including myself, believe that this is a hint towards some kind of starting point where to begin in decrypting the Liber Primus. And a lot of people who read this pick up on some key words in here that kind of stand out, specifically in this section right here. Now, the words that stuck out to me the most were map, road, and direction. Mostly because all of these things are describing the Liber Primus. Liber Primus is the way, its words are the map, their meaning is the road, and their numbers are the direction. So these are all descriptions of the Liber Primus. Now, these three words, they all have something in common. So if we were to write these words out, or write them in a category, so to speak, so map, road, direction. So if we were to title this category, what would this be? Well, the conclusion I came to is that it has something to do with navigation, specifically cartography or maps. So for me, this is alluding to something involving navigation. Now, I know there are a lot of people nowadays who have never used a map, and a basic understanding of maps is necessary to understand what I'm about to present. So I just wanted to take a minute to briefly touch on those. So let's just say we have this really basic map here with two roads, right? A map is usually going to have a legend or something on it that will tell you which direction on the map is north. Now, let's say that I'm trying to get to a city here at the northern end of this street. And let's say that I am here. Now, in order to get to where I'm going, I not only need the map, but I need something else. I need a compass. Because based on legend in the map, I know that the city I am looking for, or trying to travel to, is north of my current location. But that only helps me if I actually know which way is north. So this is where compasses come in. Now, this is the best compass that I could find in fall, because apparently they are seasonal items. But so I've tried to draw the arrow here, which is very important. I painted that in red to make it easier to see. So we have basically two main parts of a compass here, which are really important to this theory. So we have this arrow here, and we have this dial. Now the dial is floating, and so it's always going to point to north. The arrow can be moved into the direction that you are trying to travel. So with the compass, I can basically orient my map, know that north is this way. So then I orient my compass, really terrible compass, so that the arrow lines up with north, and then I follow the arrow. If I wanted to go east on this road, I would do the same thing. I would orient the arrow to point to east on the dial, and then I would follow the arrow in that direction. So that's just a little basic understanding of how compasses work with maps. Now you need a compass in order to use a map, because you might know where you are, but if you don't know the direction that you're going in, you might end up going the completely opposite direction and end up lost. So a compass is the most important part of using a map. So now that we're all on the same page with maps and how they work, let's move on or move back to the clue here. So this is, in my opinion, very strongly alluding to navigation with a map. Now, as we just saw, in order to use a map, you need a compass. Now, this is obviously telling us that the Liber Primus is the way towards the map, so we're associating the Liber Primus with a map here. Now, the question is, if the Liber Primus is a map, where is the compass? Because you can't use a map without a compass. So where would that compass be? It is my theory that this is representative of a compass. Now, if you are looking for a compass associated with the Liber Primus, this page or picture starts to make a lot more sense. So there are a few things here that identify this image or collage of images as a compass. First and foremost is the massive compass in the middle. You know, obviously there are some esoteric occult associations with this and the way it is oriented. That kind of sends a lot of people, including myself, down the wrong path, I think, because I think this needs to be taken at face value. This is a compass, and it's right smack in the middle of the page. Now, the second thing I want to point out is the layout of the collage itself. So it is broken into 4 sections, which are aligned or oriented with the cardinal directions: north, east, south, and west. Now, looking at this image on the collage specifically, if you this is just a snippet of the image, but if you look at the whole image of this, this is an image of William Blake's Urizen. Urizen is, in the Blake mythology, one of the 4 Zoas, and the 4 Zoas are associated with the 4 cardinal directions. And Urizen, who this is an image of, or partial image of, just happens to be the Zoa that is associated with the south. So we have Urizen, the god of the south, or Zoa of the south, in what I'm interpreting as the southern portion of this collage. The most important thing that associates this collage of images with the compass is the orientation of the images that make up the collage. So the first thing that is noticeable about this is that the images have been manipulated. They have had a combination of flips and rotations done to them. So this top image has been flipped. This one has been flipped and then rotated 90 degrees. This one has been rotated 180 degrees, and this one has been rotated 270. Now, if we're looking for a compass and we take that into account, then the orientation of the images actually aligns perfectly with the degrees of a compass. So, you've got north being 0 or 360 degrees, east being 90 degrees, south being 180, and west being 270 degrees. So if this is north, this is east, this is south, and this is west, that would make perfect sense because this image has been flipped, but it has not been rotated at all. So we can consider that 0 or 360 degrees north. This image has been flipped and rotated 90 degrees, just like east is 90 degrees. This image has been rotated 180 degrees, just as south is 180 degrees. This image has been rotated 270 degrees, just as west is 270 degrees on the compass. So at this point, I'm pretty convinced that this is a compass, but I know that it can't be the whole compass because a compass has to consist of two individually moving parts connected together through a central axis. So if we take a look at our cheap little compass here again, you'll see that it basically has two parts. So you have the housing, which contains the arrow or the pointer. That's the important part here, so the pointer. And then you have the dial. The dial has all of the important information on it. The dial stays stationary as the pointer moves around it and points to the pertinent information on the dial. So, and they are held together by that little silver thing right there. So they're held together at the same central axis, but they need to be two separate pieces so that the arrow can actually point to different information on the dial. So if I'm looking for a working compass, I know it's going to have to come in two parts because one part stays stationary with the information on it, and the other part has a pointer on it, which points to information on the dial. So these are parts that I'll be referring to as pointer and dial. So if I had to wager a guess, I would say that this is the pointer. In no small part thanks to the finger, the pointing finger, right here. Now, as a lot of you may know, this is actually pointing to something that's kind of hidden here. You can't see it on this really cheap print that I made, but if you look at it on a computer, you'll be able to notice that there is some pixel distortion here, and it looks very much like a 3301 in Roman numerals. Now, I believe that is there to simply draw your attention to the point at the end of the finger, the area that this finger is pointing to. And I'll get more into that later. But right now, if I'm looking for a working compass, I need a pointer and I need a dial. And I'm going to go ahead and say this is the pointer based on the pointing finger. So if this is the pointer of the compass, then we know we need to look for the dial. The dial being the stationary object that has all of the actual information on it. Now, the dial, I believe, is one of the most neglected images associated with the Liber Primus. The actual image of the Gematria Primus. So there are the data associated with these, with this image that most people just kind of pull the data off, the order, the letter, the value, things like that, and we work with that, and that's what I did most of the time too. It wasn't until I printed this out and started playing with it that I realized that there's something more to this image. So if this is the pointer and this is the dial of our compass, then we know that we need to put them together and have them swivel around a central axis, just like in our compass here, so that the pointer can point to relevant information on the dial. Now, I'm sure there's a more high-tech way of doing this with GIMP or Photoshop, but I like working with paper. So what I ended up doing was I took one of these plastic sheets, put it over the cover image, and I outlined all of the important geometrical points on here, the lines, and including the finger, which is the most important part, the pointer. So now I can remove this. I have that left, and I can now use this as an overlay on this. So what I've gone ahead and done to turn this into a working compass of sorts is I've taken the Liber Primus image here, and I have stapled it to a piece of cardboard, 2 pieces cardboard actually. So now this is where the fun part really begins, or at least the interesting part. So if you line it up perfectly, first thing you'll notice is that the finger, this is the tip of the finger that I outlined here, the finger is pointing directly to a rune here. And you can consider it pointing to a row as well. It says pointing to ordinal 24, as I've written here, letter A. Now, as we saw with our little compass here, the 2 pieces need to be held together by a central point here. That's what allows them to spin around freely and allows the pointer to point at specific or different information on the dial. Now here's the fun part. If you noticed this triangle here, which in the painting, the collage is, looks like a drawn triangle. It comes to a point right here. And that point, within about 30 pixels, give or take, is right in the center of this collage. So that point I've outlined right here. So what we're going to do is we're going to take a thumbtack and we are going to put it right at the top of that triangle. Now we have a working compass. Now, as I'm sure many of you have already noticed, there are already several different ways that we could do this. Just based on manipulating the pointer alone, we could flip it one way, we could flip it another way, have different starting points, and we are going to get into all of that. But right now, we're going to be concentrating on one specific transformation because I think that is the transformation that Cicada wanted us to find first. And I just find it very interesting based on what I'm going to go into later about the symbols in the Liber Primus and how they relate to this compass. So let's just take a look at the most basic transformation here that's happening. So first of all, when it's originally set up, the pointer, or the finger, is pointing to a rune. That rune is ordinal 24. Now, if we rotate the pointer 180 degrees, the pointer is still pointing at a certain row. This time it's pointing at a prime value associated with the rune, which makes me think that it is trying to map a rune to a different prime. One lead I haven't gone into too much yet, but right now we're just going to concentrate on what's happening here, the actual mapping. So we started at ordinal 24 down here. Here, my little bad handwriting there. So we started with the pointer pointing at ordinal 24. We're going to rotate pointer, just like we do a compass, 180 degrees. Now that pointer is pointing to the row of ordinal 4. So basically, a 180 degree transformation on this compass maps ordinal 24 to ordinal 4. Now, I find that very interesting because that is exactly what happens if you apply the at-bash transformation to the Gematria Primus. This is at-bash. If you take, for those who aren't familiar, at-bash, basically you take the ordinals of the alphabet and you map them to basically the opposite. You write the alphabet in reverse and you map it. So 0 goes to 28, 1 goes to 27, so on and so forth until 28 maps to 0. So this is the at-bash transformation. And in the at-bash transformation, we just happen to have this right here for being mapped to 24. Just like we do over here, where it's going the other way, but we're starting at 24. We rotate the compass 180 degrees, and we end up at ordinal 4. So this compass with a 180 degree transformation is a representation of at-bash. Now, if you're watching this, you might be thinking, okay, this is interesting, but it's a little ad hoc. This guy has made some pretty weird connections to get where he is. Now, I'm with you. I felt the exact same way. But when relaying a cipher method like this, especially a very complex and abstract one like this, it's not uncommon to put verification in the ciphertext, usually in a more easily translatable part of it. That way the person receiving the message who is trying to figure out the cipher method, they can look for this verification, and when they find it, they can be like, okay, cool, I'm on the right track, keep going. So I thought, Cicada, being as methodical as they are, they would probably do something like this. So I went looking, and I believe I found it. This is a part that I get really excited about. This is a part that I can't explain any other way. So let's take a look at this page. This is the first page of Koan 1. It has already been translated, and we know how, obviously. So this entire section was translated with a double cipher. It was done using the at-bash transformation, followed by a Caesar cipher, or what I'm going to refer here to as an index shift of 3. And we're going to see why. And we're also going to see why I'm concentrating on at-bash here. So this we have the ciphertext and the clear text of, and the cipher method. So this can be easily used for certain verifications. So we know for a fact that this was encrypted with at-bash followed by an index shift of 3. So basically what that means is that 4 would get mapped to 24, and that would get bumped up 3 more to 27, and that is the mapped character. Now, it was my hunch that the symbols would be some type of representation of how to orient the compass, or manipulate it or do something like that to get the proper cipher method. So I started looking, and again, when you know what you're looking for, it starts to kind of pop out. Some of you may have already noticed it. So the symbol associated with this image is this bearded man up here. But most importantly, we have this spiral here and 3 little bumps. So the spiral, I am theorizing, is representative of the @bash cipher, because that's exactly what you do on the compass to produce the @bash cipher or transformation. 180-degree turn. And then once you complete the 180-degree turn to perform the @bash cipher that we just did, then you index shift by 3. 1, 2, 3. I mean, there it is. So at this point, I'm convinced that the symbols found throughout the Liber Primus are descriptions of the cipher method used to encipher the related or associated sections. And if that's the case, we should be able to go through and identify the cipher methods if we know how to interpret the symbols. Now, I don't think that Cicada would just use one transformation. @bash is one of many transformations associated with gematria. @bash being the most common and basically simple one. So that is, I think, located elsewhere in other sections based on things I'm going to show you later. But right now, if we're going to try and identify the rest of the symbols, it's very helpful to, of course, know what we're looking for. So I just want to go over a couple gematria transformations that are very much associated to this Gematria Primus image. So as we saw earlier, @bash is a very simple transformation. You're just taking the entire alphabet, representing in ordinals here, write it one way, and then reverse it, write it, and then you just exchange horizontally. So that's @bash. That's one that most solvers are familiar with because it's been used before. But this is just one of many transformations and the most simple one. So there are a couple of other transformations that I want to go over real quick. That way we know what we're looking for. So there are 2 transformations that I want to concentrate on besides @bash. These 2 transformations are known as albam and ocbi. Now, instead of putting the entire alphabet in a single column here and then reversing it, we're going to take the alphabet and split it into 2 equal columns, or in the case of an odd numbered alphabet, as even as we can get it. So here is the basic format to perform both the albam and the ocbi cipher, or transformation. So you would make a column, splitting the alphabet in half as evenly as you can. And then albam, color code this. So albam is when you exchange horizontally between the adjacent columns. This is albam. Now the other one is excuse me, that's not @bash. The other one is ocbi. Ocbi is basically an @bash transformation on the individual columns. So you have the 2 columns split as evenly as we can. Then we take 15 and we map it to 28, just like we do with @bash. The first goes to the last. Then we take 16, map it to 27, so on and so forth. Same thing with the other side. So this is how you perform the Albam and Ocby transformation if you were to apply it to the 29 character Gematria Primus. So as you're looking at this, you may realize that this arrangement of the two columns here looks kind of familiar. And it does. It's the exact same arrangement as in the Gematria Primus image. So we have two, as equal as we can get them, columns for an odd number charactered alphabet. And just as we did here, this is set up perfectly to perform both the Albam and the Ocby transformations. So I actually believe that the arrangement of the actual Gematria Primus image itself is a clue. They're telling us that we need to do something with probably both Albam and Ocby. Now, just to review, we have three transformations that we are concentrating on. There are many more. There's a whole Wikipedia page titled Gematria that covers these three transformations and several more, along with many other cipher methods, most of which can be applied to the Gematria Primus. But these are the three that we're going to concentrate on right now, Atbash and Albam and Ocby. This is because I believe I have found these three transformations repeatedly described in the symbols throughout most of the Liber Primus. Now, before we go into actually trying to translate the symbols in the Liber Primus, we need to take a minute and go back to this. So, as I mentioned earlier, some of you may have already noticed that there are different ways of setting up this compass. So this is the standard way. You can also flip it this way, which gets you an entirely different mapping. You can start this way, a lot of different things you can do here. So there are different starting positions for the pointer that will get you different transformations on the dial. So that is something to be aware of. But more importantly, I want to talk about different ways of that these three main transformations are represented here, both between the compass and through just the Gematria Primus image itself. Now, this is where it's going to spiderweb a little bit. It's going to get a little complicated. If you're already brain fried, I understand. You might need to take a break at this point, come back fresh, because this is where it's going to start to get a little complicated. Okay, so what I discovered is that there are congruences between different ways that you can manipulate these two things, or sometimes just this, to get the same transformation. So let's take a look at that real quick. So basically there are three main manipulations, I guess it could be done to this and this, or just this, to get similar transformations. So again, concentrating on Atbash, one way of describing that is with the compass and using rotation. So as we saw, do this and it's going to map 24 to ordinal 4. So you can represent that, as we saw in the symbols on Cohen 1, as a spiral, or a 180-degree turn. Now, what I found is that Atbash specifically is not going to be represented as a spiral all the time. That would be too easy. So there are other ways of manipulating this to get the same transformation. First one is flipping. So instead of using rotational geometry, I'm simply going to flip it. So I'm going to flip it one way, and then I'm going to flip it another way. So I'm flipping horizontally and vertically. And you see we get the exact same transformation. We just moved the pointer from ordinal 24 to ordinal 4. So, as you can see, there are different ways of representing different transformations using these pieces. So, as I mentioned earlier, there are 3 main ways that I've found, at least, that the symbols will be manipulated in order to represent different transformations. Those are flip, fold, and rotate. So I'm going to use @bash as an example, simply because it's a good one to describe all 3. So first things first, align this properly, do 180, you perform an @bash transformation. Pointer goes from ordinal 24 to ordinal 4. So describing the @bash transformation with rotation, it's 180 degrees, or a spiral. If you want to describe the @bash transformation using flips, you would do it just like I showed you earlier, where you just flip along both axes, and you'll get the exact same @bash transformation. Now, the third way that this is described or represented in the symbols that I found, at least, is through folding. So, seems a little harder to see, but take this. So again, mark it for you. So we got 24, and then what was ordinal 4R. Okay. So we're gonna watch 24 and 4. That's the important part we're concentrating on right now. So if you take this image, fold it in half, one way, and then fold it in half another way, the other way, excuse me. Sorry, the image doesn't line up perfectly to the printer paper. So you gotta line it up by the black lines here. So if you fold this properly, you'll notice that 24 gets mapped somewhere to 4. So again, we have 24 here on top of 4. It's kind of bad folding, but you see what I mean here. So that's another way of describing the @bash transformation. So we have 3. We have rotation, we have flips, and we have folds. These are the 3 ways that I've found that the symbols in the Liber Primus describe cipher methods, or transformations at least. There may be more. These are just the ones I've found so far. Now, I know this is a lot to keep track of. I kept getting mixed up trying to work with it myself, so I went ahead and made this little congruence chart for you. Basically just kind of telling you which manipulations of the compass or the GP image result in which gematria transformations. So as I listed up here, flip and fold, flipping and folding the Gematria Primus images I showed you, that results in the same transformation. They're just represented, I believe, differently in the symbols in the Liber Primus, which is why it's important to mention the difference, flip and fold, but as far as the transformations they produce, they do the same thing. So f of x is just flipping vertically or flipping horizontally. So we have the at bash here. It can either be represented by 180 rotation on the compass, or flip on the vertical, followed by a flip on the horizontal, or a fold of the same. Albam is going to be a flip or fold on the horizontal, or it can be represented, interestingly, with rotating the compass 180 and then flipping it. And I'll show you what I mean here. So, albam is when we are going one column to the next. So, if we combine this, if we do as the compass, if we do a 180-degree turn, that gets us from 24 to 4. But then if we pick up the compass and fold it or flip it on the vertical axis, we get the appropriate outbound transformation. As you see, just as in the outbound transformation, excuse me, 24 has been mapped to 9. So very interesting, I think, that you can represent it that same way. So that's what I mean when I say rotate 180 followed by a flip or a fold of V on the vertical axis. Then Acme is basically the same thing inverted. You have, it can be represented either with a flip or a fold on the vertical axis, or same thing, it can be represented with a 180-degree turn, and then this time a flip on the horizontal axis. This, if I can line this up properly, will get us where it needs to be for the Acme transformation, where we're going 19 to 4. So if you're trying to work with this, I find it very helpful to have this chart handy. So if you want to just go ahead and screenshot that or do whatever you got to do, that's fine. This will come in handy as we analyze the symbols found in Liber Primus, which we're about to do. All right, so if you're still with me, congratulations. This is when we finally get to start using this system to interpret some of these symbols in the Liber Primus. So, as a reminder, we started with this image, or this symbol, and we discovered that the spiral here is telling us to do a 180-degree turn on the compass, thus performing the at-bash transformation. And the 3 dots here, or bumps, or whatever they are then telling us to proceed with an index shift of 3. So that's how we're able to interpret this symbol and use it as ways to manipulate the compass to tell us which transformation is being used here. Now, I like working with the compass here just because I think it's pretty cool. But if you want this to be more explicit and a little easier to work with, what you can do is this. Take another outline, order them, label the ordinals, and then from there you can do the exact same manipulations. So if you take, same thing, if you watch 24, I'm gonna rotate it around a bit, went off a bit, 24 maps to 4. Same thing if you want to flip it. So this works for all of the transformations, Alabama, Acme, all of that. So If this is easier for you, by all means, go ahead and do this. Again, I just like working with the compass because I think it's cool. All right, so moving on from this section, the next set of symbols that stood out to me the most were these ones. Now, if you were to take this symbol, if you notice, first of all, these symbols are exactly the same. They're just oriented differently. So if you take this symbol, if you flip it horizontally and then flip it vertically, it will align perfectly with its corresponding symbol over here. And to illustrate that a little better, you can do the fold method if you like. So you take this whole page, fold it horizontally, fold it vertically, and then the symbols line up perfectly with each other, just as it did when we flip or fold, or just as it does when we flip or fold the pointer on the compass. So it's my theory that this section involves at bash. It's not at bash, obviously. We would have figured it out by now if it was. But whatever the solution for this section is, it's going to involve at bash. Now, moving on from this, the next symbol that stood out to me was this one. And you may already be catching on to what to do here. So what we're going to do, we're going to take this page, we're going to fold it in half. And now you see that the mayflies now line up perfectly with each other. Exactly like what happens here if we use the fold method. If we fold vertically, just like we do with the page, then we end up performing the Ocby transformation. And a better way to see that is if you want to do it with the compass and the flip method. Basically, folding and flipping are the same thing. So if you take the pointer and do the same thing, it will perform the appropriate Ocby transformation. Now, I've already tried Ocby on this section, and it did not translate it. So the same thing as with the last symbol we saw, it's not going to be that straightforward. It's not Ocby by itself, but however this section is translated, it's going to involve the Ocby transformation. Now, moving on from this one, I want to show you one more, just so we have an example of all three of the transformations I'm talking about. So the next one I want to point out is this. So as you may notice, these symbols are mirrors of each other along the horizontal axis. So if we take this page, fold it horizontally, the symbols end up matching with each other perfectly, which is the exact same thing as the Albam transformation. If you want to do the fold method on this, that is going to map 24 to 9. I don't have it marked, but order 9. Or if you want to do it over here with the flip method, the same thing. You could take this, flip it, and it is matches up that symbol there. So if you want to take this and flip it horizontally that same way, that is going to line up 24 with 9, which is the same as the Albam transformation. So again, same thing. I tried Albam here, didn't work. So whatever the solution for this section is, it's going to involve, I think, Albam. So that is the end of this video. Now, there are quite a few things that I didn't include in this video because this was, already complex and long enough. I am eager to share the rest of the things that I've discovered with the community that I don't believe the community has discovered yet. I just don't necessarily know how active the community is since I've been working solo up until this point. So, I don't want to spend my now limited time and energy making videos that only a couple of people are going to watch. So if you are interested in more videos for me to elaborate on this or to publish some more information related to the Liber Primus that I think could be equally important, then go ahead and subscribe to the channel. That way I know, approximately how many people are wanting more. Based on that, I will do my best to release as much the information as I can. Hopefully together we can brainstorm this and finally solve this puzzle.